The standard model of cosmology is dead. The James Webb Telescope has detected monsters 13 billion light-years away. We found objects 10 billion times more massive than the Sun. They defy the laws of fusion. They are not galaxies. They are the firstborn of the void. Dark stars. Invisible matter. Igniting the cosmic dawn. Everything we knew about the beginning of time was wrong. The observation begins at the edge of the known, where light ceases to be a particle and becomes a memory, recorded by 18 gold-plated hexagonal segments, positioned 1,500,000 kilometers from Earth. The James Webb Space Telescope, functioning at temperatures below 50 Kelvin, was launched to resolve the ultimate mystery of our origins, the era of reionization. For decades, the scientific community operated under the strict parameters of the Lambda-CDM model, a mathematical framework where cold dark matter dictates the structural evolution of the universe. According to this protocol, the first hundreds of millions of years following the Big Bang were a period of dark ages, where gravity slowly, painstakingly, coalesced primordial gas into small, fragmented stellar nurseries. But the data stream received in late 2022 and throughout 2023 initiated a systemic crisis. The near-infrared camera, or NIRCam, captured photons that had been traveling for 13.4 billion years. In the sector designated as the JADES survey, the primary investigative team expected to find protogalaxies, faint clusters containing no more than a few million stars. Instead, the sensors recorded high redshift anomalies, objects that were already massive, already mature, and radiating with a luminosity that defies hierarchical merging theory. These are the spectral signatures of JADES GS-Z11, Z12, and Z13. The presence of such density so close to the cosmic dawn, approximately 320 million years after the initial expansion, is an analytical impossibility within the standard model. To reach such mass, these structures would have needed to form stars at a rate hundreds of times faster than physics allows, or they would have needed to begin their growth long before the Big Bang theoretically permitted the formation of matter. Astronomers found themselves staring at a cosmic clock that had bypassed its own gears. The resolution of the NIR-SPEC instrument allowed for a deeper extraction of data, revealing that these objects lack the typical distribution of light associated with hundreds of billions of individual stars. Their profile is concentrated, intense, and singularly focused. This led the research group led by Katherine Freese, Cosimo Ali, and Gillian Paulin to propose a radical shift in perspective. If these are not galaxies, they must be individual celestial bodies of a scale never before witnessed by human instruments. We are observing the potential verification of the dark star hypothesis, a theoretical construct that has waited 15 years for an observer capable of seeing into the infrared abyss. A dark star is not a gravitational pit, but a gargantuan cloud of hydrogen and helium, stretching over 4 billion kilometers in diameter. Its volume is large enough to engulf our entire solar system multiple times, yet its surface temperature remains relatively low, near 10,000 Kelvin. Unlike the Sun, which is compressed by gravity until it ignites through nuclear fusion, these entities are expanded, bloated by an internal energy source that does not depend on the collision of atoms. They are powered by the annihilation of dark matter. This is the point where the analytical watch transitions from observation to forensic investigation. If dark matter, specifically weakly interacting massive particles, or WIMPs, exists in high concentrations within the early cosmic filaments, then gravity would have pulled this invisible matter into the centers of the first gas clouds. As these particles collide, they destroy one another, converting 100% of their mass into pure energy. This process creates an outward pressure so powerful that it halts the contraction of the star, preventing it from ever reaching the densities required for fusion. The result is a stellar phantom, 1,000,000 times more massive than the Sun, radiating with the intensity of an entire galaxy, yet remaining a single, coherent object. The discovery of such an entity would not merely add a new category to our stellar catalogues, it would dismantle the current understanding of how the universe structured itself from chaos. We are looking at a dawn that was never supposed to happen, a period where the darkness itself became the light. The data from the JADES survey, specifically the redshift 13.0 candidate, remains the most potent evidence of this shift. If the spectral lines continue to match the dark star profile, the Lambda-CDM model, the foundation of modern cosmology, will have to be declared obsolete. We are no longer observing the birth of galaxies. We are observing the reign of the giants. To understand the mechanics of these primordial titans, we must descend into the subatomic architecture of the early universe. The theory, formulated by Katherine Freese, Doug Spolier, and Paolo Gondolo, posits that the invisible scaffolding of the cosmos is not merely a passive gravitational anchor. It is an active energy catalyst. During the first hundreds of millions of years, the density of dark matter in the centers of emerging halos was several orders of magnitude higher than in the modern era. This environment provided the critical mass for a phenomenon known as self-annihilation. Dark matter particles, specifically the neutralinos predicted by supersymmetry, act as their own antiparticles. When they meet within the dense core of a cooling hydrogen cloud, they do not merge, they erase one another, releasing a cascade of gamma rays, neutrinos, and high-energy leptons. This is the engine of chaos. While a standard star like our Sun converts only 0.7% of its mass into energy via fusion, dark matter annihilation is nearly 100% efficient. A fraction of a percent of dark matter by mass is sufficient to power a star 1,000,000 times more massive than the Sun for billions of years. The analytical implication is staggering as we pause to consider the fundamental shift in our perception of the cosmos. The data suggests that we are at a crossroads of discovery. If you find value in this forensic reconstruction of our origins, ensuring the continuation of this analytical watch is vital. Subscribe to the Event Weaver as we document the dismantling of old realities and join our investigation into the fabric of the unknown. The internal structure of a dark star defies every convention of stellar evolution. Because the energy source is distributed throughout the gas cloud, rather than concentrated in a tiny, ultradense core, the star remains incredibly diffuse. Its density is less than 1/100000th that of the Sun. It is, quite literally, a glowing, superheated ghost. A person standing within the outer layers of a dark star would perceive only a faint, shimmering nebula, unaware that they were inside an object radiating with the power of 10 billion suns. Katherine Freese's mathematical models indicate that as long as the dark star is fed by the surrounding reservoir of dark matter, it cannot die. It does not suffer from the instabilities of massive fusion stars, which burn through their fuel in a few million years and explode as supernovae. The dark star is a patient predator. It continues to accumulate ordinary matter, growing larger and heavier, becoming a celestial sponge that absorbs everything in its gravitational reach. Spectral observations from the JADES survey provide the critical evidence. Mature galaxies contain a diverse population of stars with varying temperatures, resulting in a broad spectral profile. However, The data from objects like Z13 shows a specific, singular temperature distribution. This suggests a single, monolithic surface, not a collective of billions. The light we are seeing is the thermal signature of a surface that is 10,000 times larger than the orbit of the Earth. The energy balance is precarious. If the supply of dark matter particles drops below a critical threshold, the outward pressure of annihilation begins to fail. The Titan, which has held itself against the crushing force of gravity for eons, begins a slow, agonizing contraction. This leads us to the most significant contribution of the dark star theory to modern cosmology, the solution to the mystery of the supermassive black holes. For decades, astronomers have been unable to explain how black holes with masses of 1 billion suns could exist only 700 million years after the Big Bang. There is simply not enough time for a standard black hole to grow that large by feeding on interstellar gas. But a dark star, having already reached 1 million solar masses before it even begins to collapse, provides a massive head start. It is not a seed. It is a fully formed engine of destruction. The physics of this transition marks the end of the era of light and the beginning of the era of the abyss. As the dark matter fuel is exhausted, the gargantuan cloud collapses with a force that shatters the local space-time fabric. It does not explode, it implodes, leaving behind a singularity of immense proportions. We are witnessing the birth of the monsters that sit at the heart of every galaxy, including our own. The stability of a dark star is a temporal illusion, sustained only by the invisible rain of dark matter particles. As the primordial filaments of the cosmic web shift and expand, the local density of WIMPs begins to fluctuate. For a standard star, the depletion of fuel leads to a supernova, a violent expulsion of heavy elements. For a dark star, the end is silent, absolute, and exponentially more massive. When the heat from annihilation can no longer counteract the inward pressure of millions of solar masses, the Titan undergoes a direct collapse event. This is a critical juncture in the analytical record. Conventional black holes, formed from the death of fusion-driven stars, begin their existence with a mass of only 10 to 20 suns. To reach the scale of 1 billion solar masses, as observed in ancient quasars, these black holes would need to feed at rates that violate the Eddington limit, the physical ceiling for how much matter an object can consume without pushing the rest away with radiation. The dark star hypothesis removes this theoretical bottleneck. By the time a dark star exhausts its dark matter engine, it has already accumulated enough ordinary baryonic matter to reach a mass of 100,000 or even 1 million suns. When the collapse occurs, it does not create a small seed. It creates a massive singularity, a monster born fully grown. These are the seeds of the abyss, the primary gravitational anchors around which the first true galaxies began to crystallize. The thermodynamics of this collapse are extreme. As the 4 billion kilometer cloud shrinks, its core temperature skyrockets, briefly reaching billions of degrees before the event horizon swallows the light. This process explains why the James Webb Space Telescope sees such high concentrations of mass in the early universe. We are not looking at the slow birth of civilizations. We are looking at the remnants of a titanic era where the largest objects to ever exist were forged and destroyed in a cosmic instant. Data from the NIR SPEC instrument reveals another anomaly that supports this forensic reconstruction: the absence of heavy elements. In mature galaxies, the light is filtered through the remains of previous stellar generations, enriched with carbon, oxygen, and iron. However, the candidates JADES GSZ11 through 13 show a pristine chemical profile. They consist almost entirely of hydrogen and helium. This is the hallmark of a first-generation object, a relic from a time before the first supernova had even occurred. The transition from a dark star to a supermassive black hole is the missing link in the history of the cosmos. Without these titans, the structure of the universe as we know it would not exist. There would be no central engines to hold together the sprawling spiral arms of galaxies like the Milky Way. Our own existence is a secondary effect of this primordial carnage. As we analyze the final moments of these giants, we must recognize that the dark matter was not just a fuel, it was a structural necessity. It allowed matter to congregate in volumes that the laws of nuclear physics would otherwise forbid. The seeds of the abyss were planted in the dark, and the harvest is the very architecture of the sky we observe today. The forensic evidence is clear. The giants did not just vanish, they became the foundations of reality. The observation begins to solidify through the resolution of the NIS spec instrument, allowing for a deeper extraction of data, revealing that these objects lack the typical distribution of light associated with hundreds of billions of individual stars. In late 2024, the research community began processing the high-resolution spectroscopy of the JADES candidates with unprecedented scrutiny. The objective was to find the Balmer break, a specific spectral feature that acts as a fingerprint for the age and composition of stellar populations. In a standard galaxy, this break is blurred across various frequencies. In the candidates observed by Webb, the break is sharp, localized, and consistent with a monolithic stellar surface. This is the final evidence required to shift the dark star from a theoretical curiosity to a primary cosmological contender. If these are confirmed, we are not merely discovering a new type of star, we are witnessing the collapse of the Lambda-CDM framework as an absolute truth. The Standard Model, which has reigned for 30 years, cannot integrate the existence of million solar mass objects appearing 300 million years after the Big Bang without significant, and perhaps fatal, modification. The implications extend far beyond the early universe. If dark matter can power a star, it proves that the mysterious particles we have been hunting for decades, the WIMPs, are indeed capable of non-gravitational interaction. This would be the first direct detection of dark matter's internal physics, bypassing the failed experiments in deep underground laboratories on Earth. We have found the laboratory of the cosmos, where the densities are high enough to force the invisible to become visible. The analytical rigor of the scientific method demands the exhaustion of all alternative explanations before a paradigm shift can be officially ratified. Critics of the dark star hypothesis frequently cite the potential existence of supermassive population 3 stars, hypothetical fusion-based giants composed purely of hydrogen and helium. However, the data from the James Webb Space Telescope creates a specific thermal contradiction for this counter-theory. A fusion-powered star of 1 million solar masses would possess a surface temperature exceeding 50,000 Kelvin, emitting a violent ultraviolet flux that would ionize the surrounding medium instantly. The candidates detected in the JADES survey remain consistently cool, radiating at 10,000 Kelvin, a temperature signature that is functionally impossible for a fusion engine of that scale, but perfectly congruent with dark matter annihilation. This distinction is not merely a matter of degree, but a fundamental divergence in stellar architecture. The Mid-Infrared Instrument, or MII, is currently scheduled for deep integration cycles that will focus on the spectral region surrounding the helium-2 emission line. In a standard star cluster, this line should be prominent due to the high-energy photons of young, hot stars. In a dark star, the helium-2 line should be entirely absent, as the annihilation process lacks the ionizing energy to strip the second electron from a helium atom. This absence will serve as the final forensic confirmation. If MIRI reports a null detection of helium-2 in the coming observation cycles, the existence of dark stars will move from a high-probability hypothesis to a recorded scientific fact. Furthermore, the implications for the missing mass problem are profound. For decades, the cold dark matter model predicted that dark matter particles must congregate in the deepest gravitational wells. By observing dark stars, we are not just seeing a new celestial body, we are seeing dark matter itself in a state of high-energy interaction. It will bridge the gap between cosmology and quantum mechanics. The Event Weaver records that as of 2025, the scientific community has begun to abandon the notion that the early universe was a simple, linear progression from gas clouds to galaxies. We now recognize it as a high-energy era of dark-powered titans, where the rules of the game were dictated by forces we are only beginning to comprehend. The James Webb Space Telescope has not just pushed back the horizon of the visible, it has forced us to acknowledge that the foundations of our cosmic history are anchored in the invisible. Our investigation concludes with a final analytical certainty. The universe is far more efficient at creating complexity than our models predicted. The Dark Ages were never truly dark. They were illuminated by the annihilation of the unknown. As the James Webb Space Telescope continues to peel back the layers of time, we must be prepared to discard the old protocols. The truth does not care about our consensus. It only cares about the evidence recorded in the infrared. This has been a forensic reconstruction of the impossible dawn. The watch continues.